Okay, today's topic is olives. And olives, of course, grow in the summer. Um, as they ripen, they start to change colors. Um, they go, as you could see in the picture, for those of you watching on video, they go from being a dark green. Then they get a little to different colors, shades of greens. They become like a reddish brown, and eventually they become like a purplish color, as you can see all the way on the right. Um, excuse me. And eventually they actually turn black. That you don't see that here in the pictures. They do eventually. They turn black as they change colors. They become softer and softer, and the taste changes somewhat, and they get a higher percentage of oil. To the point that olives that are black are basically never going to be used for eating. They're too soft and mushy that anybody's going to want to eat them. Instead, those are the ones that are used that are left on the trees and are used for making oil out of them, to squeeze to make olive oil out of them. Now, I know that lots of people have seen black olives. We're going to talk about what black olives are in a second. But the olives that are actually grow black on the tree, those olives tend to get saved for oil and not for eating. Now, so the most common olives that people will see are the green olives. And one exception to that rule is one exception of most people see as green olives is the Kalamata olives. Okay, now Kalamata olives, tend to be sold in the darker, like the purplish, reddish, brownish colors. If you see here in the picture, they wait to harvest them till later when these colors. You might see some greener ones in there. Those are called blondies. Blondes, those are not the most desirable ones. But there's a difference aside from the color. Is that aside that these are sold in these colors, is that there's a little bit of a different shape. A typical olive is very round, while Kalamata olives are more elongated, and they tend to have like a pointy-ish edge at one end of it. Excuse me. Tends to be a pointy-ish edge. Anyhow, so that there are actually many other different varieties of olives, but for most consumers are concerned, there's two kinds: there's green and there's Kalamata. Okay, and as we'll see, there is a difference in how they're processed, and that does have an implication for us Kashrus wise as well. Okay, now olives are harvested in the fall, somewhere this September-ish time until about December. This depending on what color you want them to look like. And what happens is like this: as soon as the olives come in, now again they come in at one certain time of the year. When they come in at that time of the year, they need to be stored for the whole year. That's a whole year's worth of produce. So what happens is that when they first come in, the olives are put into these very large tanks, and the tanks. Oops, there goes me again. The tanks are filled with acid and salt water, which is to say, the bulk of what's in there is a salt water. It's a saltwater brine, which is about 8% salt, which is quite a large amount of salt. As you see in the chart, it's compared to the ocean. The ocean is about 3.5% salt. So this is quite a salty mixture over here, salty brine over here, to help preserve the olives, and together with that is an acid. In most cases, at this stage, what you're going to see is lactic acid or citric acid. Okay, some kind of an acid to put into there, and that adjusts the pH down all the way down to about 4, which is, in a relative sense, that's quite acidic. And what happens is that starts the processing of of the olives. But an important part of what goes on at these points, or in much of the processing of the olives, is that there's something in olives that makes them too bitter to eat. That is, I hope I pronounced this correctly. Oleoropine. I don't know if I pronounced that right. It's some kind of a water soluble material that's inside of the olives, and it makes them very bitter. It's water soluble, so by sitting in the water, that helps leach it out of the olives. But also, the salt water also breaks apart the bond between this oleoropine and sugar, so they separate. This bitter substance leaches out of the olives, and the sugar that's in there begin to ferment and release its own lactic acid. Okay, and we'll see how the process goes on as we continue. So they sit in these tanks, in the storage tanks that I showed beforehand, and they sit there for they sit there for weeks or months on end until they're ready for further processing. But while they're sitting there, they themselves are already beginning to cure or to ferment. Okay, now once they come out, then the first thing when they come out of those is they get sized. As you see over here in the machines here, they're being sized into all different sizes, and they get sized by valves that come in, maybe 8 different sizes. Excuse me. And put into different barrels, depending on their size. This way, they can be marked and used later on as appropriately. Okay, so here you see lined up. They've already sorted all these olives, and now they put them into these drums. These orange, reddish, different. Or some of them are black drums. These big plastic drums, and again refilled with the same brine that was in there beforehand. Brine with some kind of an acid into there, so they should sit into there. Some people also, at this point or sometimes at later points, will do pitting, remove the pits out of the olives if that's so desired. And then there's something else. Let me go back on this for a second. Oops. I can't go back. And that is, many people are familiar that there are these red peppers that are inside the olive. If they pull out the pit, they put in these red peppers. Well, sometimes they might be real red peppers, but in lots of cases, what you're seeing in this machine over here is what looks like a red pepper. It's really starch and coloring and all kinds of stuff that needs hashgacha being put in. You see it comes here on a strip. It just gets chopped down to look like a piece of pepper. I'll play it again. It looks like a strip over here. In fact, so it's not actually a pepper at all. Anyhow, and then once that they put it back into the drums, if at any step, everything that happens, they do a little processing, put it back into drums, and put it back together with the same mixture of brine, salty water with some kind of an acid mix into it. Okay, now there are two major ways to process olives. Okay, which is what we're going to talk about. The first is what most people are familiar with, what they call green olives. That's what they look like when you buy them in a jar. They're green, and those are processed with saltwater curing. Again, I'm going to talk about the two main ways of curing it. There are other ways with just plain salt or just plain water. There are other ways, but we're going to talk about two ways. Excuse me, and the most common one is what I've been describing until now is the saltwater together with some kind of an acid. And what that does is it leaches out the bitter part of it. It's called to de-bitter the olives, and creates fermentation, and gets the olives to the state that they are, that people should be able to eat them. Now, there are those I've read. I'm not sure if this is accurate. That say that in order to get this is a fermentation, you want some live cultures. They may actually pour in some old brine from a previous batch into this. In which case, we have to just think about Kashrus wise if the previous batch wasn't kosher. But that's what to think about. Now, some of the customers who are buying olives are ready to buy the olives just in the drums. They're going to bottle them themselves or use them in some kind of a process. So they will, once the olives have cured for long enough, they get put back into the drums that we saw beforehand. They get put into the drums, and that's it. They're ready to be sold to the customer. Okay, but and the brine that they're in, the brine and the acid that they're sitting in, is enough to keep them from spoiling, and I guess continues the curing and the fermentation as well. And they're ready to go, and they're that's enough for their processing. When they get sold for retail use, then it's in most cases that's not considered to be good enough. Not always. There are some people who put it into jars and assume that the pH of 4.0 is acidic enough that nothing will grow in there, and they'll put it in. Some people put a little oil in there to avoid mold forming on the top of it. But a lot of times it's the jars of olives, the retail size jars of olives, are pasteurized in something called a tunnel pasteurizer. A tunnel pasteurizer, as you see here in the picture, is this long tunnel The jars of olives, if you're looking at the picture on the right side, you can see them coming out of the tunnel pasteurizer. And they what it is the jars pass through this very long tunnel where very hot water pours onto it, and that hot water that's pouring onto it brings it to a certain temperature that's enough to kill any pathogens that are living inside there and prevent it from spoiling further. Now, I mentioned beforehand that the brine that they use the brine that's used for making green olives is typically lactic acid and citric acid. Of those two, lactic acid is the preference because citric acid has a citrusy flavor, a lemony flavor to it, and that's not necessarily considered good. So lactic acid is the preference. Lactic acid is what actually forms itself as the sugars ferment. It's a sort of byproduct. It's sort of a natural byproduct. So citric acid. So the typical use is lactic acid, as long as lactic with a mixture of a certain amount of citric mixed into that. Okay. Now all of this that we've been hearing until now, in particular, the acids that are used is the way it's done for green olives. But when this saltwater brining, we're still on our first method, which is the saltwater brining method. When that's done for Kalamata olives, when that's done for Kalamata olives, then the lactic acid and acetic acid are not commonly used, and rather what people will use is red wine vinegar. Okay, and the reason is because I'm sorry, they use wine vinegar and acetic acid. I'll explain what that is in a second. The reason why they don't want to use lactic acid is because lactic acid tends to lighten the color of the olives, which is perfectly fine when you're making green olives. That's considered okay, that the color gets a little lightened. That's not considered a negative. However, for Kalamata olives, where one of the prime features that people look for is the purplish, reddish color that's there, making it a lighter color would not be desirable. And therefore, lactic acid is typically not used when making those olives. Rather, traditionally, what was used was acetic acid. What used was red wine vinegar. That's also acidic, so it helps preserve the acidity of what you might not make, but without ruining the color of the food. Now, in some of the more modern ones, and particularly ones who are trying to be kosher, red wine vinegar tends to be not kosher. Wine tends to be stam yain unless made under special conditions. They will use acetic acid. Acetic acid is the acid that's in wine vinegar, and it has the same effect. Actually, it's cheaper and easier for them to deal with. You need less acetic acid than red wine vinegar. So there are companies that will use that. But again, they try to avoid using lactic acid because it affects the color, and it affects, actually I forgot to mention, it makes it softer as well also. And therefore they would rather use red wine vinegar or acetic acid. Now, when we spoke to a company that does this, we said to them, how much wine vinegar would you put into a typical batch? And they said about 5%. Now, 5% is an amount that's not going to be batal b'shishim. 5% of wine vinegar mixed into the olive batch is not going to be batal b'shishim. But what you might be thinking is, okay, but there's a din that stam yain, which is the concern here for the red wine vinegar, that it might be stam yain. Stam yain is batal b'shisha. It just needs 6 times enough to be batal, and of course 5% is enough to be batal in 6. And it's actually even lower than 5%, because 5% is 5% of the brine will be the acid, will be the wine vinegar. But there's also olives in there as well to help in the bittul. So you might think that it's batal b'shisha, and there are 3 reasons why that appears to not be correct. The first is, and these are both rules that have to do with bittul b'shisha. Bittul b'shisha works when stam yain is diluted in a beverage, and the reason why it works is, what Moshe explains, is that when wine that's diluted in 6 times its volume is no longer has the character of wine, and since it doesn't have the character of wine, it also loses the dinim that go along with wine. And therefore, it loses the din of stam yain and it becomes mutter. That's the mechanism by which it works. And for that reason, when stam yain gets mixed into a food, it needs 6D times to be batal. 6 is not enough. And that's because when it goes into a food, it's not being judged as a diluted wine, or is it a wine or is it not a wine? It's wine inside of potatoes or in some kind of other food, and therefore it needs 60 times. So it's only when the stam yain is being diluted as a beverage into another beverage, and that's the case where 6 is what makes it be bottled. So now there are two reasons why over here, seemingly why it should not be bottled. The first was what Shechter said is that vinegar is not a beverage. Wine is a beverage. So with stam yain in wine form or grape juice in that form, when it's bottled in another liquid, could be bottled b'shisha, but in 6. But when you have vinegar, nobody drinks vinegar. It's not considered a beverage, and therefore bottled b'shisha doesn't work. Rebelsky brought a whole slew of proofs that that's not accurate. That vinegar actually can be considered to be a mashka, a beverage. But he had other reasons. He himself had other reasons to think is that we should not be allowed bittul and shisha, because that vinegar has a very strong taste and it shouldn't be bottled in 6 times. So one potential reason why it's not bottled is because the vinegar might not qualify to be bottled with shisha. But another reason, in this case seemingly a stronger reason, is that what is the vinegar being diluted into? Is it being diluted into saltwater brine? Saltwater brine that's at 8% salt. It's saltier than the ocean, is not something that anybody drinks. It itself is not a beverage. So whether the vinegar is a beverage or not, it's not relevant, because it's not being diluted into a beverage. It's being diluted essentially into another food, into salt water mixed with olives. That's a food, and in foods, stam yain needs to be bottled in 60. It needs bittul b'shishin. So we're going to work with the assumption that this brine that the Kalamata olives are sitting in, with its 5% vinegar, is usher. There's no bittul b'shisha, and that brine is usher. Now, if the brine, excuse me, assuming now that we've come to that conclusion that the brine is usher, now we have an issue, and that's because the equipment, that same equipment, the same processing that's done for the green olives is for the Kalamata olives is done for the green olives. So that means to say is that the olives, the Kalamatas, and the green olives share a couple of pieces of equipment. Let's deal with them one at a time. One is the tunnel pasteurizer. After the olives are already in a jar, they go through this tunnel pasteurizer in order to heat them up to a point that they don't spoil later on. So this actually is the smallest part of the shiloh, because here we're talking about a belia having to go through. The jars tend to be glass; they're not always, as long as they're metal. They have to go through into the tunnel pasteurizer, into the water, and then back into it. Into the water, there probably is bittul b'shisha. Going through the Daifnei Hakli is probably bottled also. So it happens to be that, as a rule, we probably would not worry about the tunnel pasteurizer from just because of a belia of stam yain. However, the other two issues are more serious. One is the middle picture that you see in front of me, which is the brine tanks, which is around the factory. That every time olives are moved from one place to another, they go from the big tanks into drums, from drums into another drums, from the next drum into a jar. Wherever they move, whenever they move from place to place, the brine that they're in gets thrown out, and they get new brine put in. Which is to say, is around the factory there are brine tanks all over the place, there to pour brine into them. Well, if the same brine tank is used today for the brine that has the wine vinegar in it, and tomorrow it's used for the saltwater brine, then that tank needs to be kosher before it's used for the kosher brine. The fact that it held once the treif brine means it needs to be kosher. Bear in mind that in these issues, brine, it makes kavush happen. Tzir makes kavush happen in just 6 to 18 minutes, in a very short amount of time. It's very quick that the blia happens. And not only that, but the blia that comes out is machai leila shvach, means, which is to say, is even if it's eina ben yomoy, it'll make the next brine not kosher. And eina ben yomoy doesn't work for this kind of thing, because we're talking about tzir and dabacharif. It's both of them actually, and therefore that's not going to help. So the brine tanks would need to be kosher. And the third issue is the drums. As I keep mentioning, the olives go into and out of drums, can go into and out of drums more than one time. Which is to say is that today this drum held Kalamata olives with their wine vinegar. Okay, and it sat there for sure for 6 to 18 minutes, but for sure it could have sat there for a week, could have sat there for 6 weeks. Afterwards, it's emptied out, they rinse it out, and they fill it up with the next olive, with kosher olives. So here we have the olive company could have hundreds, dozens, hundreds of these drums, of which if any drum was ever used for Kalamata with its wine vinegar, that drum is now going to be not kosher. So, and to think about how to kasher these is very complicated. Most of these plants don't have access to hot water to be able to do the kashering that it would need. You can kasher with milu v'irui, but in this case, just without getting too deep into it, milu v'irui, the rule is you can do milu v'irui with any liquid, but there's one exception. You can't do milu v'irui. The Shach says you can't do milu v'irui with wine. Or Shach explained that means is if the blia happened with wine, you can't do milu v'irui with wine again, because milu v'irui works by diluting the tam that's in there. So you need to have a different liquid for the dilution. You can't use the same type of liquid. In our case, that means is the dilution has to happen with something other than brine, other than saltwater brine. You have to use something else, and having and using. So you'd have to use plain water. Plain water will work fine, but that means is you have to go to each one of these drums would have to be emptied out and done milu v'irui on it 3 times, which is an amazing job that would have to be done, especially because the companies function. They need to have all these drums to function to hold their products in. So it sounds like a nightmare. The good news is that since the amount of vinegar is only 5%, assuming we don't have to be choishish for Hanan because of the hefset over here to deal with these, trying to do milu v'irui on all these hundreds of drums, we can say that the blia that's in there is the drums qualify as asur l'shtamish b'shefa. The blia that's in there is just 5% treif, probably even less than that because of the olives. It's let's say 5% treif, so that any blia that's in there will surely be balta b'shishim into the olives, the kosher olives put later, and we could be samech that kli asur l'shtamish b'shefa could be used without being kasher. Again, the sheet is mechaber, especially when it's any binyamin, like in our case. And hopefully that's a good enough reason to be samech, to be mekel, if a company wanted to switch over. But it's what to think about over here for sure, that we have they have this shared equipment over here. Now, what we've been talking about, these idea that a person might use the wine vinegar, it's traditional and it's logical to use it when you're making Kalamata olives. There doesn't seem to be any good reason to use it when a person is making plain green olive, not Kalamatas. Doesn't seem to be any reason why someone would want to use that, and therefore the inherent concern that there should be wine vinegar in there seems to be very small. It happened again, as I mentioned. Companies who want to be kosher have been moving to use acetic acid, and actually in Europe at least, you're allowed to, if it has diluted acetic acid, you could write vinegar on the jar as the ingredient. You can't write wine vinegar, but you can write vinegar. I don't believe you could do it in the United States. Here you probably have to write acetic acid, but companies have been moving to do that as a way to be able to be kosher without having to deal with all the complications of having treif wine vinegar in the plant. Okay, now up until now, we've spoken about how to make green olives or kalamatas, which are processed in a very similar way to the green olives. And particularly that they are debittered through the salt water and acid, and then they are and cured to that to be made edible. Again, eventually, then they're bottled, etc. Now, there's a whole different type of olives, and those are called in most of the world they call those black oxidized olives. In the United States, we call them black ripe olives. Okay. And this is a quicker way to make olives. As I've been telling, the saltwater method is a method that takes many months. It takes a long time to draw out the bitter agents, to ferment the sugars that are in there, and to make the olives again be suitable for eating. But this method, it uses caustic soda / lye, the same thing. Uses caustic soda to make olives to get rid of the bitter agent that's in there very quickly. Okay, actually, takes days. Within a week, you can make the olives ready to be eaten. Okay, and what happens like this? in order to do this, uh, what they do is the olives are put into again. They start off all in the saltwater brine with the low pH, just to keep them from spoiling. But when they're ready to process them, they put them in these tanks, like you might see them over here. They add caustic soda and air. Okay, you can't read Greek, but the pipe on the left says air on it. At least in Greek it says that. And what they do is by and that's why it's called these are called oxidized olives, because the presence of the caustic soda and the air causes the olives to turn a dark black color. Okay, the olives again. So the caustic soda is burning away or destroying this chemical, the chemical that's in there, the oleoropin, whatever we pronounce it, that makes it taste bitter. Okay, so the taste is not coming from curing and slowly fermenting. So the black olives have, aside that they're very different color, that these dark, that literally are black. Excuse me, but they also have a different taste because they haven't gone through this curing process. And this process goes through different stages. First, they do is very strong caustic soda, very strong caustic soda, and then they have a lighter caustic soda. But the long and short is that the caustic soda is what's doing the trick to get the bitter part out of it. Of course, when they're finished, they wash off the caustic soda. Nobody wants to eat it with that. And what happens is that once they washed it all off, they use the caustic soda as a base. So it has a high pH of 13, 14, very high. They wash it all off. Give or take, the olives come back to being approximately a pH of 7. That's like the neutral, like a water is. And they're not at all protected. They're not at all protected from spoilage. Okay, I'm going to explain in a minute what that means to us, why that makes a difference, and what we do, how that plays a role. But first, before I get to that, I'm going to talk about one more step that happens in the process right over here. But again, what my point for here now was that the caustic soda would make them a base, which would be like 13 or 14, a very high basic, which is the opposite of being acidic. The base is all washed off, leaving us with olives that are not, they're black. They're olives that are not bitter, but the olives that would spoil. They don't have a low pH, and they would therefore spoil. How we deal with that is going to come in a minute. But for now, there's one more step in the process that's almost always done, and that is that they add to the mix after the olives are just about ready. They add something called ferrous gluconate. The ferrous gluconate helps in solidifying the color of the olives to the point that they look like you can see here in the picture as what people are used to. These black, they're black, and actually in the picture they're not so shiny, and other ones they'll be more shiny. But it gives them this color. Now, ferrous gluconate has two elements to it, and the iron part, the ferrous part, and the gluconic acid, that's the gluconate. In Europe, where lots of olives are made, in certain Spain, Greece, a lot of those countries in around the Mediterranean. In those countries, it is common that this ingredient will be chametz stick. This ferrous gluconate will be made from chametz. Now, that means if you wanted to, you obviously can't put a chametz ingredient into something that you can make kosher Pesach. So you wouldn't be allowed to make this. You wouldn't be allowed to add that in. This type of ferrous gluconate that's chametz in to make one that's kosher Pesach. Okay. What about a person to keep them over Pesach? Should a person be concerned that the ferrous gluconate is in there? Now it's in tiny amounts, and amounts that are tiny, but that are batal b'shishim. But let's think about for a second. What is the role of the ferrous gluconate? So it's not easy. Almost everybody uses it, but I found the company that makes olives without ferrous gluconate. For whatever reason they do that. They have this thing that they're proud of this. I tell you, they make this without ferrous gluconate. And here I'll show you on the screen what those olives look like. These are the olives I'm about to show you are sold as black ripe olives, meaning olives that are gone through this process with caustic soda, and exactly like we've been talking until now, but then specifically don't have ferrous gluconate. Those olives come out looking basically brownish. Okay, not black. They have a brownish color to them. Okay, now here's a question. It appears that the ferrous gluconate is making the difference between, is changing the olives from being, again, these olives came into the machine a week ago. They were all green, these olives. They went in green. Through the process, through the caustic soda, affected the color, among other things, to the point that it appears that it turned them to this brownish color. Now, ferrous gluconate takes that brown color and makes it tell us to make it look black. If I'm accurate in what I'm talking about, it's not clear. But if what's not clear is that there are those who seem to think that it doesn't make them black; it just keeps the black color from leaking out. But if it's correct that the ferrous gluconate converts it from being brown to being black, then we have an example here of something that causes chazusa, something that causes the color to change because of a certain ingredient. And the rule is like this: if something causes color, it's a big machlokes whether chazusa should count or should not count. Can it be batel? Could it not be batel? The Pri Chodesh says is, which most people follow. The Pri Chodesh says is that when something is asher midaraisa and it causes a change in color, we should be machmer and assume that it is not going to be batel. Even if it's in tiny amounts, it cannot be batel. It has this dramatic effect of causing a new color to come into this food. And that's chazusa. In this case, chazusa is milsa, and it cannot be batel. That means is that in this case, the ferrous gluconate, which is chametz, which is asur midaraisa, since it's asur midaraisa, it cannot be batel. It's midrabanan that it can't be batel, but it cannot be batel, and therefore it appears that it would be asur to keep those olives, again, made particularly in Europe, not such an issue in the United States, if they're made in the United States, but if they came from Europe, then it would appear that it would be asur to keep those olives over Pesach because it has chametz in there that's not batel. The chametz is in tiny amounts, but because it affected this change in color, therefore it would not be batel. Now, if someone did keep it over Pesach, then seemingly the olives would be mutter, because there's another rule, and that is, if something is asur midaraisa to keep over Pesach, and you did the wrong thing, then you can't eat it after Pesach. It's chametz of Pesach. But if something was only asur midrabanan to keep over Pesach, then it does not become asur as chametz of Pesach. Seemingly that's what's going on over here. Chazusa not being batel is on drabanan. Again, chazusa milsa only applies when the isur under discussion is an isur deraisa, which it is. But the fact that it's not batel is a rabbinic principle, and therefore seemingly the food would be mutter if someone kept it over Pesach. Okay, now back to our processing for one last bit that we have to talk about, and that is like this: the acids that are used. There is a little bit of acid used in making these black oxidized olives. There's acid at the beginning of the process, just stored in just temporarily until it's ready to be processed. And then what happens is, again, I told you that you're using this caustic that's in there. So they wash off as much as they can. A little bit of acid will be added at the end just to neutralize it, to keep it from being too basic, just to get it to the neutral state of about 7, of a pH of about 7. So a little bit, you'll see it on the ingredient panel, so a little lactic or citric acid we put in. No reason why anybody would put in wine vinegar at this point to use that for this little bit that they need. They would use lactic acid or citric acid. Okay, now, however, but I've told you that the finished product is it has a acidity of just about 7%, a pH of about 7, give or take 7. Not at all protected from spoilage. So that means is this item would not be processed in a tunnel pasteurizer. Or at least not the tunnel pasteurizer that's used for the green olives. Because that one doesn't nearly get hot enough to do the processing that's needed for the black olives. Rather, the processing that would be done for these olives would be, they would be put into a retort. That's typical. They would be put into a retort. Retort, you could see in the corner there are baskets. They put the jars in. They stick them into this machine, this retort. In this case, it's a horizontal tube that they stick into it. It can cook things at a very high temperature. For things like this, where the pH is not low like like the other ones are. This has a pH of about 7. This would need a very strong amount of processing, and there's not a real concern that a person would process the black olives on the same retorts as the green olives or the Kalamatas. So it's possible. You can, and in some cases they do, it is possible to put the green olives into the retort. The retort could be adjusted to cook not as strongly. It's possible when need be that it can be done. It's not typical, and therefore it's not a strong concern that would happen. So if we think about it, the black olives from a Kashrus perspective have minimal concerns. The green olives have a concern that they might be processed and use shear equipment together with the Kalamatas that were made with wine vinegar. And I mentioned a number of places where they share equipment. On the black olives, there isn't that much that potential for them sharing. there is, I guess, they could share drums. They could share the brine tanks. Those could be. Well, no, actually, they would not be sharing brine tanks because the brine that's used for this is just salt water. The brine that's used for the black olives is just salt with a drop of lactic acid. Someone has added in just to adjust pH. But the drums could have been used. But as I mentioned, any bleas coming out of the drums are always going to be bottled. And as far as the tunnel pasteurizer, there isn't really a concern that they're going to share the tunnel pasteurizer. So the black olives have much less of a Kashrus concern, excuse me, than the green ones do. The green ones do, where the green ones have potential that they were used on equipment that was shared for the Kalamatas that were made with wine vinegar.